My name is Tom Bobo, Director of Technical Sales and Marketing for Business Development for Split Engineering and Hexagon Mining. I'm here to present a holistic approach to the drill and blast process with emphasis on fragmentation. I want to present our mission at Hexagon. It's putting data to work to enable autonomous connected ecosystems that boost efficiency, productivity, and quality for our customers. The key to this is what we're talking about in our closing the loop of the integrated drill and blast portfolio. One of the things that we're going to talk about here is the solutions that Hexagon has that can help you with your drill and blast portfolio. And what we're looking at is, to start off with, is our mine plan blast, and that's where we design our shots. And the next thing that we go into, once we design the shots, it'll tell us where the holes need to be, and then those hole positions can be sent over to a drill using Hexagon's Mine Operate OP Pro Drill HP. And once those drills are drilled out, and those holes are drilled out, and then we can do the as planned versus as actual drilled and filled with our QA/QC product. After that, we shoot the shot, and the blast happens, and we can measure the motion and the blast from our IDS radar and our Leica Geosystems technology. What this helps us do is identify blast vibration in the high wall. Then we do the analysis and measurement with split engineering using fragmentation analysis as well as blast movement technology to characterize the movement in the blast. And what we're looking at is translation of ore versus the ore versus the waste and the different positions from where it started before the blast to where it ended up after the blast. And then we have our improved loop where we're looking at all the digital information in the technology. Next, we're looking at split at a glance. So we're going to talk a little bit about the split engineering technology for fragmentation analysis. And we're looking at characterizing, understanding the fragmentation from mine to mill. We've been in business since 1997 and continuously improved for over 20 years. We are the global market leader with over 140 mining operations worldwide and presence in 68 different countries in large base precious metal mines. We're an established global leader in the fragmentation analysis systems, and our solutions drive productivity and quality improvements from mine to mill. Now I'm going to give you a little bit of a taste of some of the automated technology that we have. Measure, manage, improve. You're going to hear that from me in a little bit. And increase your profitability with shovel cam, truck cam, and conveyor cam. By Hexagon Mining. So what I'm going to talk about a little bit is our automated systems, and we're talking about our measure, manage, improve technologies. So we kind of saw on the video there that we have shovel cams. So those are cameras mounted on shovels, and we look at the muck pile face directly to measure post-blast fragmentation and give that feedback back to the drill and blast engineers. And then that material gets loaded into the truck, and we can measure the trucks as they feed into the combination circuit as well, and then downstream. So when we're looking at identifying particle size distribution from mine to mill, we're identifying these different size curves from the in situ particle size distribution, where we reduce the fragmentation by blasting, to the mechanical comminution circuit from crushing to grinding all the way through. So you can see on the x-axis you have particle size, and on the y-axis you have percent passing, and then energy. So as we get further downstream, the more energy it takes to comminute the rock and reduce the size of the particles. So this is a really cool group of curves that kind of give you the life cycle of a drill and blast all the way through the mine and all the way through to the mill. So one of the things that we can do next is we can, in the drill and blast portfolio, we can design a blast that decreases top size but also increases the fines. So we're understanding the characteristics of the in situ rock mass and how that interacts with the drilling and the burden and spacing that we put in the design, and we can ultimately design a blast to target our desired fragmentation. So this is a zone-specific blast fragmentation optimization, where we can identify different points in the process, and then we can visualize that data. So what we're looking at here is mine plan blast, and within mine plan blast you can visualize the fragmentation, but this could also be ore types or drill penetration rates. So what we're looking at on the left is a variability in the blast. So we're looking at the P80 distribution of the fragmentation. So we're seeing high variability in the blast, and then what we want to see is minimizing that variability. By minimizing that variability, you have more of a manufacturing process in the downstream, so you're having more consistent feed to the primary crusher. So this example here probably looks at a primary crusher feed where you have a high variability on the left-hand side. Perhaps they missed a hole and they had oversize due to poor fragmentation in that area. So this gives us an opportunity to say, hey, how do we do this here? And when we go on the left-hand side, when we go to the next blast, how can we improve? So it's that integrated process and closing the loop on drill and blast fragmentation. So how did we do before to how we do now? And I'm going to talk a little bit about our automated system. So we talked, you kind of saw a highlight there on the shovel cam system. So this is where you have cameras mounted on the shovel looking at the toe of the slope. And generally speaking, we're getting one pass for each bucket load as we go into fill a four-pass shovel, four-pass truck. So this gives you an idea that the x-axis here is about 5 meters and the y-axis here is about 4 meters. So it's quite a large area that get a representative sample of the post-blast fragmentation. So our muck pile measurement is very representative as we go through and dig through the muck pile. As the material has been loaded into the truck, then we can characterize the fragmentation as it comes into the comminution circuit. And we do it before the material dumps in. It gives us an opportunity to reroute a truck if we have oversize, because we want to minimize the downtime. So say in a truck, it takes about 3 minutes to crush a full truck load, and so you have between 15 and 20 trucks an hour. If you had one truck that dumps into the primary crusher that takes it down for an hour, you have to reroute 20 trucks versus just rerouting one due to oversize. So characterizing that fragmentation and doing an active process on it can yield benefits downstream. And then now we're going to look at the downstream analysis. So we're looking at not only the particle size on the conveyor belts, but the shape, color, and ore characterization. One of the unique characteristics that we have with split is being able to characterize the difference between ore and waste, ore type A, ore type B, in real time on the conveyor belt. If you can see it, we can probably measure it. So that's kind of our mantra there. With regards to image analysis, we're characterizing the particle size as usual, but also the shape and the color factors as well. So giving as much information as we can to the mill as it's feeding into the process. One of the things I want to talk about here is there's an increase in cost at each stage of the comminution circuit, whether it be chemical comminution, the blasting, or mechanical comminution, being the crushing and milling. So it's a geometric increase in cost the further downstream we go. So these are some case studies that rather than reference all the case studies, we have case studies that kind of highlight some of the interesting factors that you can do by modifying the blast to optimize fragmentation. So you can increase diggability, load factors, and reduce haulage costs by 8%, reduce dig time by 35%, reduce truck loading by 10%, decrease maintenance costs by 10%. On the milling side, I kind of mentioned about if a big boulder goes in there, how much does that cost you in terms of downtime? And this example here just shows that if we were to avoid 10 blockages, we would increase our revenue by $1.5 million. And it's probably more than that on an annualized basis. And then on the mine-to-mill side, we have some case studies where we've shown measuring from mine-to-mill, we've been able to increase throughput and having a value of over $7 million per month for operation down in Latin America. So it's pretty cool to see that. So I'm coming back to kind of a holistic drill and blast, a holistic approach to drill and blast process. It kind of, on the outer ring, it kind of defines what are the characteristics of a personnel, like what do the personnel need to do. The blue ring here is the technology that Hexagon has. And these are the kind of the trade names within Hexagon. And the inner gray ring is kind of the workflow. So we're going through the design, the drill, the blast, the dig, the process, analyze, integrate, and improve. So this is the idea behind Hexagon's holistic approach to drill and blast.